Hey guys, so in the last section we looked at how to measure angles in degrees and how to measure the measure of an angle that is positive when you have an angle in standard form with the initial side placed on the positive x-axis, and then you've got the terminal side of that angle that kind of spins counterclockwise to form a positive angle and clockwise to form a negative angle. So today we're going to look at another measure for an angle. We've been using degrees for a very long time now. Back in middle school and in geometry, you learn how to measure the measure of an angle in the form of degrees. But degrees are not the only way to measure an angle, and it's only helpful in certain areas of math. For everything else, we need to be able to describe angles in terms of radians, which is just another way to measure an angle. Just like how we can measure height and length in different measurements, we can measure your height in feet, we can measure your height in inches and centimeters, all different types of measurements. We can also measure an angle in both degrees and in radians. Radian measures is another measure that is based off of the radius and the arc length of circles. So if we consider, you got the diagram on the left that has the x and y axis, and then you have the initial side of my angle because it's in standard position. So the initial side is on the positive x-axis, and then we have the terminal side, the other ray, that kind of spins counterclockwise to form a positive angle, right? So remember we had said last time that this will be 90 degrees, this will be 45 degrees, and then this will be 180 degrees as a straight angle, 270, and then back one full circle is 360 degrees. Now, when I take this terminal side and I spin it, as it spins, an arc is formed. Okay, and so let's stop it right here. And this is the length of the arc that is formed by this angle that we're going to call alpha. So instead of using the Greek letter theta, we're using here in this diagram the Greek letter alpha to represent the measure of that angle. This angle forms the length of this arc, and arc length is just a part of the circumference, the distance around a circle. And if the length of this distance, this arc length, which we're going to call S, happens to be the same length as the radius, so my radius is r, if the arc length S happens to be exactly the same length as r, then the measure of the angle that is formed is going to be exactly 1 radian. And the word radian can be shortened to RAD for radian measure. So 1 radian is when we can fit, basically, if we can fit exactly 1 radius in the arc, then the measure of that angle we consider to be 1 radian. And similarly, if we can fit 2 radii in the arc, so if you look at the diagram on the right side, here is 1 radius, another radius. If I can fit the length of 2 radii in the arc, then the measure of this angle that is formed is exactly 2 radian measures. Okay, so basically a radian is just measured by trying to figure out, well, how many radii, how many radiuses can we fit in the arc length? And so it's a relationship between the arc length and the radius of a circle. And so if you can keep looking at the diagram on the right side, you can see that here is, if I fit 3 radii, then the measure of this angle is 3 radians. And when we get to 180 degrees, which is my straight angle right here, you can see that at 180 degrees, we can fit the length of this arc is really half of the circumference of my circle, but this distance is going to be a little bit more than 3 of the radii. So it's actually at 180 degrees, the arc length is exactly equal to roughly 3.14 radians. And exactly, it is pi radians. So in a straight angle, the measure of the arc that is formed can fit roughly 3.14 radians. And so 180 degrees is equivalent to pi radians, to be more exact. Instead of saying 3.14 radians, we say pi radians. And so we can measure the measure of each angle in both degrees or in radians. So let's take a look at that. So here we have a circle, and let's just assume that the radius of the circle is 1. It really doesn't matter. We want to determine the measure of each one of these angles that are formed. So here is my, again, initial side of my angle, and here's my terminal side that's going to spin around counterclockwise. So here's one angle. How many degrees is that? How many radians is that? The same angle can be measured in both degrees and radians. And then how about this one? How about this one? How about this one? And all of these angles, what is their measure in radian? Okay, so let's just start with the fact that, well, without opening this up, this is going to be 0 degrees and 0 radians because there's no angle that is formed. And we had just said that when I go to 180 degrees, I can fit roughly 3.14 radii in the length of this arc right here. And so 180 degrees, my straight angle is going to be pi radians, 3.14 pi radian. And this is 0 radian. Okay, well, if a half circle is 1 pi radian, then if I go all the way around in a full circle, that would be 1 pi, 2 pi, right? So a full circle, or 360 degrees, is 2 pi radian. And in most cases, when we talk about radian measure, a lot of times the word radian is omitted, and we just assume that if we don't see the little degree symbol, that the measure of the angle is in radian measure. But if you want to write RAD for radian, you may. So 0, half of my circle, 180 degrees, is pi radian. What do you think 90 degrees would be? If half a circle is pi radian, well, 90 degrees is just a quarter of a circle, right? I take pi and I cut it in half, divide that by 2, and I would have half a pi. So 90 degrees is pi over 2 radian. Okay, let me put the degrees in orange here just so you can see it. 360 degrees, here's 90 degrees, here's 180 degrees, and then down here is 270 degrees. And then based off of that, we can divide up the rest of this circle into different angles. And so pi is 180 degrees. Pi radian is 180 degrees. Half of that is 90. So half of pi, 1/2 pi, or pi divided by 2, is 90 degrees. Okay, how about 270? Well, this is 1/2 pi, half of pi, right? This is 2/2 pi. This would be 3/2 pi. So 270 degrees would be 3 pi over 2, 3/2 pi. And then from there, let's take a look at these angles right here. Okay, these angles look like if I take my pi, which is my half circle, right? It looks like I can cut it into fourths. 1/4, 2/4, 3/4, 4/4 would be 1 whole pi. So each one of these angles I highlighted is just a fourth of pi, right? 1 pi is 180 degrees. This angle right here looks like it's a fourth of that. So this angle is, I'm going to say pi over 4, or 1/4 of pi. And then, so 1/4 pi, and then another 1/4 would be 2/4 pi. And 2/4 reduces to 1/2. And then this next angle would be 3/4 pi. And then adding one more fourth, we get to 4/4 of a pi, which is 1 whole pi. And then the next angle, if I add another fourth to it, would be 5/4 of pi. Okay, 1 whole pi and 1/4, so that's 5/4. And then the next one would be 6/4 of pi, which reduces to exactly 3 pi over 2. 6/4 pi reduces to 3/2 pi. And then if I add one more fourth, that would be 7/4 of pi. Okay, and then adding one more fourth would be 8/4 of pi, which reduces to exactly 2 pi. So all of these angles are in terms of a fourth of a pi. You cut pi into fourths. Okay, how about this one right here? How about these little ones? It looks like this one is, if I take my semicircle, 180 degrees, is pi radians. It looks like I can cut this into 6 equal sections, and each one of these angles represents 1/6 of that circle. So this angle right here is going to be 1/6 of pi. So pi over 6. Okay, 1/6, and then adding another 6, the next one would be 2/6 of pi, and 2/6 reduces to 1/3. So pi over 3. So 1/6, 2/6, 3/6, right? If I count by 6, 1/6, 2/6, 3/6, which reduces to 1/2. And then the next one would be 4/6. Which reduces to 2/3. And then 5/6. And 6/6 would give me exactly 1 pi, and then the next one would be 7/6. Okay, and then 8/6, which reduces to 4 pi over 3. Okay, and then 9/6 reduces to 3 pi over 2, and then finally 10/6, which reduces to 5 pi over 3, and 11/6 of pi. So dividing the circle into a sixth of a pi. So the best way to think about how to figure out the measure of an angle in radians is to know that pi radians is 180 degrees and how much of that pi you're going to get. Let's look at another example. We want to draw these angles in standard position. So again, I'm going to start by labeling the fact that standard position, we've got my initial side on the positive x-axis, and then I have my terminal side that's going to spin around. Positive, meaning that it's going to spin counterclockwise, and then negative means that it's going to spin clockwise. okay? And I want to go 2 pi over 3 radians. So basically 2/3 of pi. So let's label. We know that this is 0 radian, and pi radian is a straight angle. That's 180 degrees. So if from here to here is exactly pi radians, I want 2/3 of pi. So just 2/3 of the way, okay? So I'm going to take my terminal side and I'm going to spin it, and I'm going to go 2/3 of the way to pi. So looks like this could be 1/3, this could be 2/3 right here. And it's just estimating, it doesn't have to be too exact. The best estimate to the best of your abilities. The measure of this angle right here, which we call theta, is 2/3 of pi. Let's look at the second one, negative pi over 2, which is really 1 pi over 2, so half of pi, okay? And negative just means I'm going to rotate my terminal side clockwise. So again, let's start by placing the initial sign on the positive x-axis. Here is 0 radian, and here is pi radian. Now, if a half circle, or if a straight angle 180 degrees is pi radian, then half of pi would be 90 degrees, right? So half of pi would be 90 degrees, and all I have to go is 90 degrees in the clockwise direction, and here it is. And so this is negative pi over 2. That would be the measure of this angle, negative pi over 2, which is really negative 90 degrees. And then that last one, 7 pi over 6. So 7 pi over 6, if we break this down, I know that's more than 1 whole pi, and 1 pi is a half circle. So this is 0 radian again, and this is pi radian. 7 pi over 6 is really 6 pi over 6, which is 1 whole pi, plus 1 pi over 6, right? 6 plus 7 6. 6 plus 1 6 is 7 6. So this is 1 pi plus 1/6 of pi. So here is my initial side. And then my terminal side, I'm going to go 1 whole pi, which is 180 degrees, and then 1/6 of that. So right here. And so this is the angle 7 pi over 6. Okay, let's look at one last example of identifying the angle measure. So doing the reverse, instead of drawing, they draw it for you. You just have to figure out what is the measure in radians. And so here is the angle that I'm looking for. I know that this is pi, and then this is, I have to go a little bit more, and which is pi over 2, half of pi, and then a little bit more, and I'm almost at a full circle. And we know that this is 0 radian, 180 is pi radian. So if a half circle, 180 degrees, is pi radian, well then a full circle, 360 degrees, would be 2 pi radian, okay? And all I have to do is take my 2 pi radian, which is a full circle, and take away this pi over 4, this little piece that is not part of my angle. So full circle, take away this angle, and what's left over would be my angle in radian. And so 2 pi minus 4, I need a common denominator. I'm going to make both denominators 4, so I have to multiply both the numerator and the denominator by 4. So that's going to give me 8 pi over 4 minus pi over 4. That's 7 pi over 4. That is the measure of that angle, 7 pi over 4. Okay, let's look at the next one. The next one, I am almost at 1 whole pi. That's almost a half circle, right? Almost 180. If it was 180, it would be pi. So if I take pi, which is right here, and I take away the pi over 3, subtract pi over 3, what's left over would be my angle, right? So pi take away pi over 3. Again, need a common denominator in order to add and subtract fractions. So I'm going to multiply by 3 over 3. So I get 3 pi over 3 minus pi over 3. That's going to give me 2 pi over 3. And remember, my angle is rotating in the clockwise direction, so it is negative 2 pi over 3 radians. And then this last one, it looks like I'm going counterclockwise, so it's a positive angle, and I rotated one full circle. Notice I'm back to where I am, one full circle, which is 2 pi. And then if I keep going, I have a half circle, which is pi radian. So one full circle plus another half circle plus this pi over 4. Okay, add those all up and we would have our angle. And again, need a common denominator in order to add. So I'm going to make all the common denominator 4. So that's going to give me 8 pi over 4 plus 4 pi over 4 plus pi over 4. Or you could have added the 2 pi and the pi to get 3 pi. Okay, so that's going to give me 13 pi over 4. So 13 pi over 4 would be the measure of that angle.